questions and the topics, are they things you've seen before? There's nothing being totally new? Yeah, really? You haven't seen that before? You only saw the other one? The binary. Okay, interesting. Right, so 5a, that's a tough one. Let's have a look at it. Page 34. Now, it says in the question that P and Q are negative. That might be useful later. No, that will be useful later, I think. Px plus q power n equals minus 64, minus 96, x, minus 48, x squared, etc. Okay? Right. Ah, no. Come on. You're a good bit late now.
I lost.
There was no one behind you, right?
Yeah.
Yeah, it's just you coming in now. Yeah? Okay. What was I saying? Oh yeah, so what we'll do, we'll expand on the left first. So we get NC0 PXQ plus NC1 PXQ plus NC2 PXQ dot dot dot, and that should equal minus 64 minus 96x minus 48x squared. Now, what is the first power on the x here? 0. Good, yeah, because you want to match it to the right. So that goes 0, 1, 2, and then what's the power on the q?
N.
Very good.
N minus 1.
Very good, and n minus 2. NC0 is 1, because it always starts with 1, if you look at the triangle. So we start off with Qn. NC1? Yeah, but you can know it in terms of n. Oh, no, we don't.
I know what n minus 1.
Well, look. Think about the triangle. It's n, yeah. If you look at this row, that's 3C0, 3C1, okay? And if you look at the next one, 1, 4, 6, 4, 1, that's 4C0, 4C1. In other words, I'm saying NC1 should be n. Okay? So that next one is NPQ n minus 1 x. Now the hard one is NC2. What exactly is that? So we need to work that out. So if I go to the side, we have to use the formula. NC2 is n factorial over 2 factorial, n minus 2 factorial. Okay? So on the top, n factorial is n times, what would be next?
N times n minus 1.
Good. Next.
N minus 2.
Next. And so on until we finish at 1. Yeah? Oh no. Who is that? Come on. And then on the bottom, 2 factorial is 2. And then n minus 2 factorial is n minus 2, n minus 3, dot, 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 1. Yeah? Yeah? Cancel, 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 cancel. So you're just left with n squared minus n over 2. That's all you're left with. Yeah? You can test it out. Like, if you had, say, 5C2, then according to my formula for NC2, that should equal 5 squared minus 5 over 2, which should equal 10. Now if you type in 5C2, let's confirm it, do you get 10?
Yep.
Yeah, so my little formula works. So I need to take that back to the main question now in a moment. I don't know if you want to write that down. Maybe you should. I don't know how many of you got that. Did you get that formula? You did? What way did you do?
I did like the first one
Yeah.
equals to the first one,
Yeah.
and then I got like this.
Yeah, I use
But-
the same way.
Yeah.
But how did you get rid of the C part, like NC2?
Oh no, I didn't use NC2, it's just NC0, and I got the N, and then I replaced it for the NC1, and then NC.
I'll look at that later. You got the right answer?
Yes.
Yeah, same method.
No, show me. I'm just wondering if this works for all the questions or just this particular one. What did you do first?
Yeah, this one equals to this.
Ah! You got the right answer by accident. Congratulations. Yeah, really. Unfortunately, going from here to here is not allowed. I know, but I'll give you an example of why it's not allowed. It just worked by accident. Let me show you why. I'll give you an example. What was the letter? It was like P and N, was it? Q and N, okay. What's Q and P? Or Q and N, I mean. 4 power 2.
2 power.
Yeah. Or 2 power 3, isn't it? Sorry, 4. So you have more than one answer. You just happen to pick the right answer by luck. Okay? That's why you can't do that, technically. So, a good try, though. Alright. You did the same thing, probably. Yes. Yes. Okay, can we go back to the main question? Yeah, so that's n squared minus n over 2. So that's n squared minus n over 2. P squared qn minus 2 dot equals minus 64 minus 96x minus 48x squared dot. Now you can compare. Yeah. So you start off by saying q power n equals what? That'll be minus 64. The first one equals the first one. And then the next one, npqn minus 1, that equals? Good. And then n squared minus n over 2, p squared qn minus 2, that equals? Yeah. Now, how the heck do we solve this? So let's have a look. What I'm going to do is take this fella and change it into npqn over q equals minus 96. Because qn over q, that's the same as qn minus 1. And we'll talk about that more in a later chapter. Okay. So this guy here, we have a couple of choices. We could put that in here for qn. So then you end up getting np over q times minus 64 equals minus 96. So that gives me p over q equals, is 96 over 64? Is that 3 over 2?
Yeah.
3 over 2n, if you divide the n down. Okay. Then what I do, in this one here, I change that into n squared minus n over 2, qn p squared over q squared. Because, again, by the same trick. But p squared over q squared is just p over q squared. Now that's nice because I can take that and put it in there. And I can take this and put it in there. So now I end up with n squared minus n over 2 minus 64 3 over 2 equals minus 48. And that's really good because now what can I do with this? What's possible to do now with this equation? I can get n, can't I?
Yeah.
What type of equation will this become? Is it going to be linear? Quadratic, yeah. So it's going to be a quadratic. So let's do some multiplication. It'll be n squared minus n equals 2 over 3.
I think it should be
Oh.
3 over 2 squared.
Oh, thank you. There should be a squared there, thank you. So that will be 2 over 3 squared. And then it'll be 48 over 64. And then the 2 and the 2 makes it 4, which I can bring up. Does this simplify to anything nice? Probably a fraction, is it?
Yeah.
What is it?
Over
4 over 3, is it? Yeah?
Right?
That looks believable. I can believe that. Right, so if we clean that up a little bit, that'll be 3n squared minus 3n minus 4 equals 0. I sure hope this has factors.
Yes and no.
Is that factors or not?
Can I
Yeah.
ask your NP, the green colored one, right?
Yeah.
The next step, your N, where did it go?
It disappeared, didn't it? Dang. Should have been.
3 over 2N. Like 3 over.
Oh, I lost it. No, wait, hang on. I replaced the qn with. No, it's okay, isn't it? I replaced the q power n with minus 64.
Yeah.
So that's a.
Where the N is.
Oh, I lost the letter n.
Oh.
Oh, yeah, I did. Dang, okay. So should have been an n here. So. Oh, but didn't I write the n underneath? I brought the n under. So the n should be here. Oh, I see. So there should have been an n here. No. Something got screwed up somewhere. Okay. Look with me, so. Here, the n is correct, yes? The p is correct. The q is correct, and this is qn, that's correct, and that's minus 96. Yes? And then, so I lost the n here, should be 3 over 2n. Okay, good, fine. And then I put that in here, isn't it? Replacing this. So that should be, so yeah, there should be an n there, isn't it? Okay. So that's no big deal. So that just brings the n up to the right. So there should have been an n squared here, which means there should have been an n squared here, which means this should have been 4n squared. Oh, wait, hold up. No, too late to come in, I'm sorry. Yeah? Yeah, but still, it's 9:21, so... No, I can't let you in. It's a little bit too late. I need to be a bit stricter now with the time. Okay? Yeah. Taking everything to the right, I get n squared plus 3n equals 0. N plus... Minus. Plus.
Minus n squared.
I made a... Sorry. I have the right answer but the wrong sign, which means I made a sign mistake somewhere. I get an answer of minus 3, but the answer is plus 3. Can anyone see my sign mistake?
It should be minus n squared. Because minus 4n squared
From
plus
different
3n should be
sides.
minus.
Yeah, but I'm taking everything to the right. Do you know?
Okay.
So it's like that minus should have been a plus. Oh. There's a minus here that I lost. I lost the minus here.
Right.
Here, the minus 64. Oh no, I cancelled it with that minus. Oh, painful. No! It's just a sign mistake. There's a minus somewhere where there shouldn't be, because the answer should be positive 3, obviously, for n. But it's mine is coming out as negative 3. Whoa, where's my minus? How did I get the minus 48? I forget. Oh no, I do. I remember now. Someone see my sign mistake? Somewhere there. Minus 96, minus 96. Minus 96, minus 64. That's 3 over 2. No minuses there. Minus 64. Oh, good grief. And oh. Yeah, I see the problem now. The n is with the 2, isn't it? So the n should have been on the top here. Yeah. So no, that doesn't help, does it? No, that's the same thing. Sorry. That's no. It's just a stupid minus somewhere.
Can I ask where is the 4 from?
This 4?
Yeah.
Where did it come from? 48 over 64.
Okay, that's from.
That's.
But the 4 is from where?
Yeah, where is the 4 coming from?
Isn't it?
That's. Yeah, where did this 4 come from actually? So is this not 4 over 3 maybe? What's 2 squared, or 2 over 3 squared times 48 over 64? What's that?
And 2
Yeah, 2.
times 2.
Times 2?
Because
Oh wait, no, I know where the 4 comes from. Oh, it's times 2, not 4. There we go. Okay. So what is this now? 2 over 3 squared times 48 over 64 times, what is it?
2 over 3.
2 over 3. So 3n squared minus 3n
Yeah, no, it's
minus 2n squared. Oh, nice. So that's going to be n squared minus 3n equals 0. N minus 3 equals 0. So n equals 3. Success. And then, once we have this, what would be the next thing to get? What would be the next thing to get? Oh, look, you can put it back in here. Get q. So you have q power 3 equals minus 64. So q is the cube root of minus 64. What's that? Minus 4? Thank you. And then once you have that, you can put it back into where... This one looks okay, doesn't it? Or wherever, whichever one you want. 3 times p over q equals 3 over 2. So what do you get here? The 3's cancel. Minus 2, is it? Minus 2. Yeah. Minus 2, minus 4, and 3. Okay. We got the answer in the end. Yeah.
The x is in the third line.
Yeah.
Why?
We're just comparing the coefficients. We're looking at the left-hand side's coefficients. We're saying they should equal the right-hand side's coefficients. There's no need to keep the x. Ah, yeah, that was a good one, wasn't it? That makes you think a lot. Obviously, you're not going to get one this hard in the exam.
You don't think so, Michelle?
I would fall off my chair in horror if it was in the exam. It's just way too long and difficult. I tried to make the workbook a little bit more difficult than the exam questions so that when it comes time to revising the exam and doing the exam, it seems a little bit easier than what you're doing in class, you know. So to me, the most difficult question you could get is maybe 4A, but really that would be rare enough. Questions 1, 2 and 3 would be quite common in the exam, this type. Yeah. Okay, what else do we need to see now?
But Michelle, question number 4, if I do the booking by like comparing, is that fine?
Oh yeah, that, like kind of like number 5, yeah. Is there another way to do it? I think I would have just compared as well. Yeah.
I had a question on the remainder theorem.
Yeah.
Question
What page is that?
It's page 24.
Yeah, which one?
6, 8.
Oh yeah, nice. What's your question?
I didn't get an answer.
You didn't get an answer.
I got like different answers. Yes,
Ah.
42 and 6.
Page 24 as well?
24 6A, isn't it?
24, 6, yeah.
I got very confused with this. Answer by very
Okay. Where did I put? Thought I had a pen. I just borrow a pen for a sec, Matar. Just. Oh wait, no, that's a pen with ink. Oh, thanks. I just want to make sure I get the right people here. So I got Vanessa and Ishmael and Diana and Priscilla, but no Umar. And I got no Joshua. I have a Patrick. Mohammed Omar, I have. Hussein, I have. Matar. Here you go. I can.
Yeah.
Thank you.
Okay. Okay, let's have a look at this one now. 15x squared plus 13x minus 6 is a factor of px cubed plus qx squared minus 45x plus 18. What are the factors of this fella?
5x plus 6.
5x plus 6, x minus 1?
3x minus 1.
Oh yeah, sorry, 3x minus 1, yeah. Is a factor of the same thing. Now, there's a little trick here. I'll show you it. Just to be clear, what does it mean to say a... there's a symbol that means a factor of. It saves me having to write it. Does anyone know the symbol? No, it's just a vertical line. So this is just short for saying A is a factor of, I don't know, K. What does that mean exactly? Say A is a factor of K.
The remainder is 0.
Remainder is 0. Yeah. So another way of saying that is that A divides into K. Yeah? Or another way of saying that is that you can say A is some multiple of K. I'll give you an example with numbers, okay? If I said to you 5 is a factor of 50. That's true, isn't it? It divides in with no remainder, right? Yeah? Oh, sorry, I wrote this backwards like a fool. K equals AN. So I can say 50 is how many multiples of 5? 10 fives, isn't it? Yeah? So if I had 6 as a factor of 30, that means 30 must be some multiple of 6. In this case, 5. So if I say A is a factor of K, that means K is some multiple of A. You're okay with that? Yeah? Alright, so let's start again then. So A is a factor of K, so K is some multiple of A. Yes? But imagine A could be written as two terms, but maybe A is B times C. Yeah? So now we can say BC is a factor of K. Yes? So what does that mean? That means K is some multiple of B and C. Yes? Now let me think where I'm going with this. Where am I going with this? I had an idea at the start which I forgot now.
Maybe if you look back at the question.
No, the problem is I'm tired, you see. That's what the real problem is. Yeah. Yes, now I remember what I'm doing. Don't worry. Okay, so I could change this fella. I could say call M times B. Let's just give that pair a different letter. Let's just call it, what letter have I not used yet? T, okay, fine, D. Right, so you can change this into K equals D times C. Yeah? This can be written as C is a factor of K. It's just the reverse of what I did at the start. And likewise, you can do the same trick and get B as a factor of K. If you do the exact same trick here, you can get the same result. This is a very long way of saying something that maybe some people have figured out already. If I go back to the question, if I have two things multiplying together and they're a factor of something else, then what do you think? Are each of these individually a factor?
There's a factor.
Yeah, but could the, so like if I had two numbers multiplying together, let's say 3 times 5, and that divides into 150, doesn't it? 3 times 5 is 15, and 15 does divide into 150, okay? My question is 3 and 5 separately, do they divide into 150? Does 3 divide into 150, and does 5 divide into it? Yeah. Now what I was trying to show you in my little proof is that this is always true, okay? If you have two things that multiply and divide into something, then individually they each do. You can think of any situation, like, I don't know, 5 times 2, does that divide into 50? Yeah. Does 5? And does 2? Yeah. Do you see what I'm getting at here? So, if I go back to the main question, if these two multiplied together divide into the cubic, then does this divide into it? Yeah, and does this? So what I can do is I can separate it. I can now separate it and say 5x plus 6 is a factor, and then 3x minus 1 is a factor. So then what do I do with those pieces of information? x equals
Negative
minus 6 over, and here x equals 3. And then what do I do with that?
Use that.
Sub both of them in.
Yes.
And then what should the remainder be?
Zero.
0. I'll get two equations with two unknowns. What are the two unknowns? P and Q. And then I can solve it. Yeah? It's messy because it's 6 over 5 and 1 over 3. Probably makes it very messy. But I don't know, do you need me to continue it or what? What's the story? Well, only if everybody's happy with it. It's going to be pig ugly, isn't it? 6 over 5 cubed. What the heck is that? Something ugly, huh?
216 over 125.
216 over 125 with a minus.
Yes.
Yeah. P plus 36 over 25 Q minus 54
Plus 50.
plus 54
Plus 18.
plus 18 equals 0. Ugh, and then 1 over 3. What's that? 1 over 27 P
Plus 1 over 9 cube.
15 plus 18 equals 0.
Plus 54x.
Where?
No.
No x, because remember I subbed in the x.
Oh, yes.
Yeah. That is ugly, but what can we do to clean it up?
54 plus 18.
Thank you. Yes, of course, we can add these two numbers together. I was more thinking about the fractions. But still, let's add them together. So minus 216 over 125p plus 36 over 25q, 64, 72? So equals minus 72. And then 1 over 27p plus 1 over 9q equals minus 3.
Yes.
Right, now really, we really have to think what would be a smart multiplication to really make our lives easier.
Times everything by 27.
27.
27 would definitely be good in the second one, right? If you multiply this one by 27 and this one by 125, but I think 3. I think, what's 12 times 27, please? 12 times 27.
324.
I think this would be a good multiplication because if I multiply by 125, they both go. Oh no, sorry, not 324. Well, it's still 125 for the top. What would be left here if I multiply by 125? 5 times 36, what's that?
180.
180. 180. If I multiply this by 27, then that's 3. How many times is 3 going to 180? 60 times. Isn't it? So 27 times 60. No. 27, 9, so what's 27 times 60?
1620.
Okay. Let's see if this works. Right, if I multiply the top one by 125, what do I get? Minus 216p plus 180q equals 9,000? Okay. And the second one, if I multiply this, what do I get?
60.
60 p. And please tell me I get 180.
180.
Ah, sweet. 180q equals
Negative 4,860.
16?
60.
60. Now, you see why I chose this number here. I could make this 180 as well and get rid of the fractions. Two jobs at once. And now what do I do? Minus them. So that would be minus 276p equals 3,140, is it? Minus 4140. Does 276 divide into that?
9,000.
Minus 9,000 plus
Yeah.
4860 is minus 4140, and it divides in 15 times. So you end up getting P equals 15. And you can sub that back into this line to get the Q.
Yes.
So what will Q equal? It will be minus 4860 minus 60 times P over 180.
Yeah.
So,
Negative 480 minus 900.
yeah, over 180.
Yeah.
So what's that in the end? Is also 15?
No, sorry. Negative 32.
Minus 32.
Yeah.
Yeah. Yeah, okay. That was a little hard, wasn't it? Yeah.
Did you do it leaving all of the fractions in?
Of course, if you like fractions. Do you like fractions?
That's what I did.
But do you like fractions? I did this weird multiplication here, so I could both get rid of fractions and match up the Q's. Because I don't have a calculator, and I want to get rid of the fractions as quickly as possible. But during the exam, you'll have a calculator. It makes no difference, right? You just carry everything with the fractions, so it's fine. It's fine. Yeah. You agree with her? Is it just leave the fractions?
No, I do it that way. I do it that
Get rid of the fractions. You don't like fractions.
way.
We're the same on this. Yeah. Okay, what else now? We've got a couple of minutes left, so we could maybe get another question done.
Page 28. 2G.
Which one?
2G.
Ah, yeah, it's great, isn't it?
Yeah.
So what happened when you tried to solve this? When you tried to sub that into that, what happened? What did you end up with? You got something like 0 equals 0, was it? Yeah. Yeah. This is on page 28. Did many people get to try this one? Page 28, the last question.
I didn't get it. I tried, but I didn't get
Yeah, so when you sub the linear into the quadratic, what did you end up with?
it.
You got 0 equals 0, yeah. What did you get? Yeah, on both sides. Yeah?
Yeah.
Is that what you got? Yeah. So this is a problem, because then how do you get x and y if they've both disappeared? Does anybody know what situation we have when you have two equations and you try to solve them, and when you do, it vanishes, it disappears?
All numbers.
Say again?
All numbers like this, which is all.
Nearly. Not necessarily all numbers, though.
All real numbers.
No, not necessarily, actually. Because there's still some restriction. You can't just pick any x and y. Like, for example, if I pick x as 1 and y as 1, then the first statement is false. So it's not all real numbers, but it's kind of close to it. Does anyone know what happens? Well, look, let's take this situation. Can anyone tell me why, if I try to solve this, I won't get an answer?
It's called identical equation.
Yeah. These two equations are identical. Can you see why?
Times 3.
Yeah, one is just a multiple of the other. It's actually, if you divide this equation by 3, you actually get the first equation. Which means you don't really have two equations, you really only have one. And can you solve it with just one? No. So this must be what's happening here. It must be that this guy and this guy, they're identical. Now, that might be difficult to believe because it doesn't look like they are. This one looks quite different to the first one. But let's have a look, okay? So the first equation Okay, so my new goal is not to solve this. I know I can't solve it because when you tried to solve it, it failed. My new goal is to prove I can't solve it by proving the two are really the same. So we need to try and rearrange it so that we can see it clearly. Now I'll keep the first guy the same. Let's try and clean up the second one here. Let's try and factorize the second fella. So the first one has to be an x and a y, and an x and a y. Now look at the back. You have 4y squared. So what could you have here and here? 2 and 2, or 4 and 1. Let's go with 2 and 2. Okay, the first one is a 5, or rather it's a minus 5. So
Minus 5 and 1.
minus 5 and 1 could do it, or 5 and minus 1. Yeah? So maybe it could be something like 5 and minus 1. And then what signs do I have here? Well, I think it kind of has to be a plus and a plus. So let's just double check this. 5x times minus x? Good. Yeah. 2y times 2y? 4y squared. Good. This will be minus 2xy, and this will be 10xy. In total? Okay, so we factorized it, yeah? Now, let's have a look at our new problem. I said, or you now want to solve 5x plus 2y equals 0, and 5x plus 2y times minus x plus 2y equals 0. But we can't solve this. This is equation 1 and this is equation 2. This can't be solved because, for the same reason here, you could say equation 2 is equal to equation 1 multiplied by 3. So, why can't I solve this? Can't be solved because equation 2 is equal to equation 1 multiplied by minus x plus 2y. So because this is a multiple of the previous one, we can't solve it. The solutions are any xy so that 5x plus 2y equals 0. If you can think of any x and y, and there's infinitely many, then you can solve it. So for example, what would be, if I had something like 2 and minus 5, does that work in here?
Yep.
Yeah? So I know, you don't need to check on your calculator, but I know it will work in this and in this. Guaranteed. But there's infinitely many. Like another possibility could have been
Can be
4
zero.
and, let me just think, minus 10. That would also work. So you actually have infinitely many solutions, not just a single one. Yeah? This is really the key to the answer. This can't be solved because equation 2 is a multiple of number 1. What makes it tricky is in high school, you probably would have only thought about the second equation maybe being a number multiple of the first. But it's still true if it's a variable. You know, so if I had something like x plus y equals 0 and x squared plus xy equals 0, can I solve this? Can I? No, it's not possible. It's the same problem. Equation 2
It's the same, just times what?
is as times x, isn't it? So there's no point in trying to solve it because I know I can't solve it. And if you sub it in, you'll get the same problem of 0 equals 0. Okay. So the key about this question is understanding that it breaks because the second is a multiple of the first. A peculiar multiple, but still a multiple. Yeah. Okay. So like I said, again, this last one is a little bit too tricky for the exam. But you know, something like, what did I give you? 2 F and G, was it?
Yes.
Yeah. I could imagine a question like 2F in the exam, but I think they would be kinder to you and give you smaller, easier numbers that don't make so many fractions. It's still the same type of question though. Yeah? When's our next class now?
Biology tomorrow.
Yeah, but our next maths, do we have maths later today? No. And tomorrow we have an hour? Is that right? No? Are you sure?
Monday.
Monday's our next class?
Mm-hmm.
I have an hour with somebody tomorrow. Not you, I guess. Okay, we'll wrap it up there. So, oh, I must have the hour tutorial with the other group. That must be it. Yeah, that must be it. Okay, we'll leave it there. So,